Alright folks, this is legit my 15th time in attempting this, so Miss Montes is getting a little irritated. Needless to say, I think I got it working. So, here we go. We are dealing with trig integrals today. This is not on your AP test, but I would like to expose it to you for your calculus class, whatever you have to take next year. Calc 3, who knows, Calc 4, all that grand stuff. Great exposure. So here we go. We've done this problem before. If you're looking at this, we want to integrate it, you should be thinking u sub, and you would be correct. Your u in this case would be cosine, because we know cosine's derivative exists within this problem. Derivative of cosine is negative sine. We already have the sine x dx, we're just missing the negative, so let's throw a negative in there. It means we need a negative out in front. So we are looking at integrating negative u squared du. Easy peasy, lemon squeezy. We're looking at a negative 1/3 u cubed. Don't forget your plus c because we have no bounds. And then we can substitute our u back in to get a final answer of negative 1/3 cosine cubed x plus c. Okay, here's the issue. What happens if we do this? Or make it cubed, or to the fifth, or we make cosine to the fifth? We change the powers up, that's going to change how we integrate it. That is ultimately what section 7.3 is looking at. Okay, so let's jump to the notes. In all of these techniques, there's really going to be one of three scenarios. We'll work through all three of these. And all three are going to deal with one of our trig identities that we learned back in back in pre-calc. A lot of times we like to use this one because that's the easiest to manipulate, the Pythagorean triple, or Pythagorean identity, but we will see when we need to use the other two. So first example, we are looking at if sine is an odd power, cosine is an even power. So that's going to fall into our first category. When you go to pick which one of these we are looking for, we're ultimately looking at the odd power. The odd power is what's going to drive this process. Now what that process is we are going to separate out one of those odd powers. Oh, by the way, that O is our odd symbol. I think we've talked about that before, but in case we haven't, it is. We are going to separate out our odd power, which means sine will now be left with an even power. And then we still have cosine to whatever number power it is, x dx. From that point, what we will then allow to do is we are going to rewrite our even powered trig function as a cosine. And that's where our identities are going to come in. We're going to convert that even powered sine to cosine. From that point, we will then just distribute, and u sub it up. Okay, so let's see what this looks like in example 1. Separate out our sine. So we have sine x, sine to the fourth x, cosine squared x. This becomes useful because we can rewrite sine to the fourth as cosines. How will we do that? We will use our Pythagorean identities. If we solve for sine squared, we know that will just be 1 minus cosine squared, and then we can substitute that in. Dilemma though, it's not sine squared, it's sine to the fourth. Well, you all are smart. If you square a square, you get a fourth power. So in other words, sine squared, we know, is 1 minus cosine squared x, and that would be squared. So in other words, you legit can think of sine to the fourth as sine squared x squared. That's ultimately what we just did there. And then we substituted 1 minus cosine squared for sine squared. Alright, let's keep writing the rest of the problem. We now have cosine squared x dx, and that is the rest of the problem. Okay, algebra kicks in. We know how to square binomials. Hopefully you are not distributing the squared. That would be math jail. Instead, we're going to multiply out the binomial. So this will turn into 1 minus 2 cosine squared x plus cosine to the fourth x. Still have our cosine squared x dx, and we're actually very close. Let's distribute our cosine squared x out to our first parenthesis. Leave that lone sine x alone. That's going to come into play when we do our u sub. So we're looking at cosine squared x minus 2 cosine to the fourth x plus cosine to the sixth x dx. And finally, we've gotten it down to u sub. Our u is, whoa, not sine. That would defeat the purpose here. Our u is cosine. That makes du negative sine of x dx. Missing the negative. Throw it in, throw it out. So we are looking at the negative integral of u squared minus 2u to the 4th plus u to the 6th du. Easy peasy lemon squeezy. Let's integrate, and for the sake of writing, I am also going to rewrite our u's with cosines. So we're looking at negative 1/3 cosine cubed of x. Other warning, before I continue, watch your negative. I'm actually going to use parentheses here so I don't mess that up. You could distribute as you go, but chances are you forget. I know I have, and then you have a negative mistake on the easiest step. So I'm going to put the negative out in front and just keep integrating. Okay, next term we're looking at negative 2/5 cosine to the 5th, and then 1/7 cosine to the 7th. No bounds, so we need our plus c. Questions? Ha, too bad, I'm not there to answer them. Alright, next scenario. Flip-flop it. Now let's let cosine be the odd power. Folks, same exact process. Sine stays whatever number it is. Cosine will now get separated. We will take out one cosine, which will leave cosine with an even power. We will then rewrite our even-powered cosine with sines. We will convert it to sine. And then our integration technique will be the same. We are going to distribute and do some u sub. See that camera moving here? Alright. Example number 2. We do have bounds. That is okay. We can deal with bounds. Again, odd dictates what we are doing. So we are looking at odd man out. The odd man is out. That's another way of thinking of it. Take out an odd, just one of them. That leaves us with an even. And we are going to use the same exact identity. Cosine squared is just going to be 1 minus sine squared. I'm going to do two things here. Substitute, and I'm also going to rewrite my, whoops. I'm going to rewrite my cosine squared first. So in other words, my 1 minus sine squared I'm going to do first to make it easier to distribute. No manipulation needed. This is direct substitution since it's cosine squared. Don't lose your cosine x dx at the end. Okay, distribute. Bounds have not changed. We are looking at sine to the 6th x minus sine to the 8th x. And that is all still in parentheses because it's technically getting multiplied by cosine of x dx. And now our u sub can kick in. U cosine x du. Goodness gracious, I did it again, folks. You want your u to be what you have all the powers of. So our u would be sine of x. That makes our du cosine of x dx. And since we have bounds on this one, let's go ahead and change our bounds right now. Sine of 0 is 0. Sine of pi over 2 is 1. So we are now integrating from 0 to 1 of u to the 6th minus u to the 8th du. Perfect match, no manipulation needed. Alrighty, you know what to do. Easy peasy lemon squeezy. Antiderivative of u to the 6th, 1/7 u to the 7th minus 1, goodness gracious, minus 1/9 u to the 9th. And that's getting integrated from 0 to 1. Don't need to change our u's because we changed our bounds. Now we just plug it in, 1/7 minus 1/9. Technically we also plugged in 0. I'll write it for notes just so we know we did it. And now we get to do some basic math. Don't do the basic math wrong. If you write 0 over -2, you're kicked out of this class. Goodbye. Good luck. We need common denominators, so we're looking at 9/63 minus 7/63. 9 minus 7 is 2/63. Okay, last one. What happens if we have even-powered trig functions? Example 3, you will see we have an even-powered trig function. You will also notice there is no sign. Because there's no sign, we know u substitution is going to be a little interesting. / not possible in its current form. Well, this, folks, is where these two are going to come in. If you have even-powered trig functions, we can rewrite it using one of the two trig identities listed up there. 1 minus cosine of 2x over 2, and 1 plus cosine of 2x over 2. Now again, there might be some manipulation needed depending on what your power is, but this will now allow you to where everything is going to be terms of cosines. There will be a little bit of u substitution in here since we see there's going to be a 2x, but that's fine, we've dealt with that before. So from this point, what we are looking at doing is we are looking at, let's distribute first. We would distribute, then we would separate our fractions. Separate, hopefully I spelled that right, I usually don't. So once you distribute, we're going to have fractions within there. We can separate it so we then have just individual terms. And then we will sub it up and integrate. Okay, example 3. Cosine squared of 3x. Cosine squared, I'm going to write it over here so I don't have to keep moving my paper. Cosine squared is 1 plus cosine 2x over 2. It's just squared, so it turns in direct substitution. Where we have to be careful is it's not cosine squared of x, it's cosine squared of 3x. So what that means is our x is getting replaced with 3x. So when we rewrite this, this will turn into 1 plus cosine of 6x. We're taking our 2 times 3x. Denominator doesn't change, that's still over 2. And now we can separate our fractions. I'm actually going to separate the integrals as well just to make it nicer. So I'm going to write it as 1/2 dx plus, and I'm going to pull the constant out of our second integral. That also has the 1/2, and then we are just integrating cosine of 6x dx. First one, easy peasy. Good job. I'm just looking at 1/2 x. Second one, we will have a little bit of u substitution with this. I'm not going to write it out. You can if you want to. Our u is 6x, which means our du is 6 dx. So we're missing a 6, which means we need a 1/6 out in front. So we're looking at 1/12. And the integral of cosine is sine. And then the 6x, which obviously stay. And no bounds, so we need our plus c. Quick check. Derivative of sine 6x would be cosine 6x times 6. 6 times 1/12 is 1/2. So we did it right. Okay, folks. So that's trig integrals in a nutshell. I will have a second video for the back side.